So hello guys and welcome to the another video of data structures using Java. In this video we will be implementing the singly linked list. First of all we will check what does exactly the singly linked list means, and then we will perform the three operation in this video. That is, first of all we will be checking insert at start, and then we will check out insert at end, and then finally we will learn how we can traverse a linked list. So I highly recommend you to watch this video till end. Just the one prerequisite for this video is we have already discussed what is the structure of the linked list. During that video I discussed how we can write the code for linked list. So if you haven't watched that video, I highly recommend you to go and watch the video. So let's first discuss what does exactly the singly linked list means. So if you observe carefully to this diagram, is in singly linked list every node contains two parts. The first part contains a data and the second part contains an address. Now whose address is this? It is holding the address of the next node. For example, if you see this is the node which contains a data as 6, which is this part, and 300 is an address, which is the address part. Now the question comes, what does a 300 means? The 300 is an address of its next node which is pointing to it. Similarly, my second node is pointing the address of this next node, which is this 500. So this is what address indicates. It simply indicates the address of the next node. And the data part simply means what kind of data you want to store in your linked list. It is not necessary that it will always have the integer. It can have a character, floating point, string, integer, whatever it may call it. So this is what a singly linked list means, that it always contains a two part, that is the data part and address part. The second important thing to note over here is that since every node is holding the address of its next nodes, which means I can move from the first node till the last node, but I cannot come from the last node till the first node. The reason behind this is, if you observe carefully to this node is holding the address of its next node, but it is not holding the address of its previous node. But in order to traverse, you should also know the address where that node is located so that you can reach there. So from 4 you cannot reach to the 2, because the node which contains a 4, it is not storing the address of the node which contains a 2, but it is storing the address of the node which contains a 1, which means you are moving further. We are not allowed to have the backward traversal, you are only allowed to have the forward traversal. So these are the two things that you need to keep in mind. So this was all about the singly linked list. Now how we can access the member of the node? As we discussed right now, that every node contains a two part, that is data part and address part, and this is my whole node, and the name of the node I have given as a node. Now let's suppose I want to access the data part. How can I access the data part? So simply, in order to access the data part, you can write it as node, whatever the name of the node which you have given. As of now I have given the name of a node as a node, so I wrote the node dot and data, whatever the part you want to access. Now let's suppose I want to access the address part. How can I access this? I can simply write as node dot address. This is what I can write. This is especially done in Java because Java doesn't support the pointers, but when you go in C and C++ language, we are dealing with the pointers, right? So this will not work in C and C++ because there we are dealing with the pointers. So I hope so you got the clear idea how we can access the members of the node. Any member of the node simply we can access using the dot operator and the name of the node which you want to access. So now let's move on to our first operation, that insert at start. Now what we need to do is we need to insert the node before my first node. For example, suppose this is the node which I want to insert, and let's suppose it has the value as 9 and the address of is this, let's suppose 400 is my address. And as of now, if you observe carefully, that 7 is my first node of the linked list. But what I say now, I want to make this node as my first node of the linked list. Now let's suppose if I name this node as a new node, let me give it name as a new node, and I want this new node to be the first node of the linked list. And we always know that the head always points to our first node of the linked list, and now the head is pointing to the 7, which means this is the node which is my first node of the linked list. But what I say now, I want to make 9 as my first node. So what I need to do is I want to make sure that my head points to this. Okay, my head should point to this, but before my head points to this node should also contain the address of its next node, that is 7, right? Because as of now 7 is my first node, and if I insert a node before 7, the 7 will become my second node. So therefore this node should be pointing to this node. Now how we can access this? The new node dot address. right? New node dot address, and it should be pointing to my this address. Now where is this address located? If you observe carefully, that head is holding the address 100, and 100 is an address of my first node, and here also I need 100 so that it can point to this node. So can I say that I will simply write new node of address is nothing but as head. So what will happen here? It will contain 100, so this will be pointing to this position now, and again I will change it as head is equal to new node. Now what is happening? Head is equal to new node, so this will get erased because now I'm assigning the address of the new node to my head. And what is the address of new node to my head? That is 400. Now see what happened. Initially my head was pointing to my 7, now it came to the 9, and the address of the 9 is holding the address of its next node, that is 7. So this is how we basically insert a node at start. Simply we need to write the to statement, that is new node dot address should point to the head, and head which was pointing initially to my second node, we should bring it to our first node. So I simply did head is nothing but equals to new node. Now let's suppose I want to insert one more element before this. Before this I want to insert one more element. How can I do it? Let's suppose I have created the node which contains the value as 10 and address is, let's suppose, 700. Now what will happen? Observe carefully. The new node, right? The name of the node is new node. Now what I did? New node of address is equal to head. Now what is the address head is containing? 400. Okay, so here it will come as 400. So this is pointing to this, right? And now my head is pointing to this node. I need to bring it to this node because 10 now become my first node. So what I will do is head is equal to new node. So my head which was pointing to this, it will start pointing to this node and it will simply contain as 700, right? Now if you see carefully, my 10 become the first node, this is my second node, third node. So this is how we insert the element at start. But there is one problem in this. What is that problem? The problem with this is, what if my linked list is empty? Let's suppose my linked list is empty and my head is initially pointing to a null, and I ask you to insert the element at start. How can I do this? And so simply what I can do is, let's suppose I created the node and which has the value 7 and address is 100, and at any time if my head is null, which is nothing but my linked list is empty, and my linked list is empty, which means the node which I have created now is itself is my first node. So simply what I need to do is, I need to simply assign head is equal to new node, right? So this will initially contains a null and my head will be pointing to this node which contains an address as 100. Now if you observe carefully, that the node which I have created itself became my first node of the linked list, right? So I need to make sure this is the first condition I need to write. What? If head is equal to null, which means my linked list is empty, therefore the node which I have created itself will become my first node. So simply I need to bring head is equal to a new node. Otherwise what I need to do is, I need to make sure that new node of address, or next whatever you may call it, is equal to head, and I need to bring head is equal to new node. This is what I need to do is. So this is how a code we can write to insert an element at start. So I hope so that you came to know that how we can insert an element or the node at the start of my linked list. So let's move on to the IDE and write the code for this. So in the previous lecture we discussed about the structure of linked list, right? In that video what we did is we simply created the package called as the linked list. Inside that package I created the class called as the linked list, and this class mainly indicates whole linked list. And inside the class linked list I created one more class called as node. What does it indicate? So class linked list indicates my whole linked list, and the class node indicates a single node in my whole linked list, which contains the two parts. The first part contains a data and the second part contains a next, which basically stores the address of the next node. And I declare the constructor, whatever the data you are going to insert in your node, it should be assigned to this data, and by default the next should be pointing to the null. So what I'm going to do is, I'm going to create a function called as insert at start, and I'm going to take a data. So first of all I need to create a new node, right? So what I'm going to do is node new node equals to new node, and data which I'm going to insert I pass to this constructor. And what I need to do is, now my head is equal to null, then what I need to do is, that node itself is my first node, right? So simply I will do head is equal to new node, right? Otherwise if this is not the case, then what I need to do is, I will simply need to do as new node dot next is equal to head. Now I need to bring that head to the first node, so I will do head is equal to new node, right? So this is the simple code we can write. Now if I call this function inside the main method, so how can I do this? First of all, I need to create the object of this class, right? That is linked list. So I also imported the package over here. So let's call it as a list is equal to new linked list, and then what I did is I simply call list dot insert at a start, right? Insert at start, and I need to pass the element, let's suppose 10. So this is what I did, and now I call the function over here. Now as of now I won't be able to traverse the linked list because we are not discussed that concept. So just remember, this is the code to insert at start. I will write the comment over here, insert the node at start, right? Insert the node at the start. So this is simple, right? First of all, we created the node itself. If my head is equals to null, which means my whole linked list is empty, therefore the node which I have created itself will become my first node. So simply assign the head to that node, and then what I did is, if my linked list is not empty, if it contains already some kind of elements in it, I'm going to simply add the address inside the new node of next equal to head, because head is initially pointing to my first node, and the first node will become my second node after inserting the element at start. And simply I brought the head to the next, that is to the new node. So this is the simple code we wrote to insert a node at the start of the linked list. In the next video we will be discussing how we can insert a node at the end of the linked list.